Let's talk about vectors and vector addition more specifically. And I'll throw in subtraction also. Subtraction is not a huge concept, especially if you do it from an algebraic point of view. Subtraction is as easy as the subtraction you learned back in kindergarten. So vector addition. If I have two vectors here, and again, a vector has a magnitude and direction. I think first let's just take a look at it from a graphic point of view. If I want to add these two vectors together, it doesn't matter with which one I start. I just pick one and I redraw it. Now they have a specific magnitude and a specific direction, so I need to redraw it. Now ideally I would put down a protractor and establish it that way, but I'm just going to do quick and dirty for the moment. So I have a vector that's that long at that angle. So those vectors should be the same length and the same direction. And why don't we call this A and call this one B? So this is A. Now the second vector is, we are now starting at this point, and I'm now going to draw the second vector. And that's vector B. So the sum of the two vectors is a vector from where I started to where I ended. And we'll go for a stunning visual effect here. So I'm basically going from there to there. This is the vector A plus B. This is also known as the resultant, and the only time that I use the double print. So that's the resultant. And that's how you add them graphically. It's known as the head-to-tail method, or tail-to-head. I generally do head-to-tail method. What I've done here is a very crude drawing of it. I didn't pull out a ruler, I don't have a specific scale. But a couple things here, that when you're doing it this method, that the length that you draw it has to be proportional to the actual magnitude of the vector. And so this vector is longer than that vector, therefore this represents a larger magnitude than that. This also sets up very nicely into adding them algebraically, or using trig, depending upon how you want to do it. So let's take a look at adding them where we actually have values here. So let's say I have vector A. This is not necessarily the same vectors I had right there. So 5 meters and 30 degrees. And then vector B, why don't we make it 7 meters, negative 50 degrees. So this first vector right here, 5 meters, 30 degrees. Now, there is an accepted standard here that 0 degrees is this way, this is 90 degrees, 180 degrees, 270 degrees. I am assuming, and then 360 degrees. Or going in the other direction, this is negative 90 degrees, negative 180 degrees, negative 270 degrees, and then negative 360 degrees. And then you can just keep going in one direction or the other. This is the standard. I am assuming that this is what you are using unless you state otherwise. Unlike I hat and J hat, where you do need to declare it, and K hat, this is an assumption that I am making unless you state otherwise. So this first one, I'm just going to sort of roughly sketch. And that's going to represent 5 meters and 30 degrees. The other vector, 7 meters, negative 50 degrees. Well, if that's 5, this next one has to be longer. And I'm not being real precise here, and that angle is horrible. So that's probably closer to it. It should be longer than that one, and so just roughly, and maybe just a little bit longer there. So that's negative 50 degrees. And so if I add them graphically, doesn't matter which one I start. Let's sort of middle of fingernail. So this is my A, and this is B. My resultant should be from where I started to where I ended. And we can come up with a crude idea of what our resultant is here. If that's 7, 7 comes to about there. This tiny bit here, that's 7, it looks like about 2. So it's going to be roughly, very roughly, 9 meters. And my angle looks like about negative 30 degrees. So I have a crude approximation of what the answer is. Now let's actually go through and do it more formally. I take this vector, so I'm going to basically break it up into components here. So I'm going to establish my coordinate system, I hat, j hat. And I am going to what's called break into components. So I have this 5 meter vector, angle of 30 degrees, and I want to figure out how far over to the right am I going and how far up am I going. Well, this is right triangle trig. This is my opposite side here. I'm going to label this P and Q. Hopefully those look different enough. So the sine of 30 degrees is equal to the opposite over the hypotenuse. The cosine of 30 degrees is equal to the adjacent over the hypotenuse. Or my adjacent here is just going to be my hypotenuse times the cosine of 30 degrees. And this one will just be the hypotenuse times the sine of 30 degrees. Pull out the handy dandy calculator or do it in your head, whatever happens to work for you. There it is. So pulling out my calculator, the real person's calculator, not that stupid TI stuff. All right, so we have 30 cosine 5 times 4.3301, and this one I can do in my head, 2.5 meters in meters. So I'm making the claim that this first vector A here is equal to 4.3301 meters I hat plus 2.5 meters j hat. My vector B, I'm going to do the very similar thing. I basically have a vector that's down like this, that is 7 meters long. This angle here is 50 degrees. I'm figuring out how far to the right and how far down. In other words, how far horizontally and vertically, because that is the way I've set up my coordinate system. So this will be 7, that's a right angle. This is 7 meters times the sine of 50 degrees. Or if you want to use this angle, 7 meters times the cosine of 40 degrees. And that's 7 meters times the cosine of 50 degrees. And this one I can't do in my head because I've gotten spoiled by calculators. So this is 5.3623, and then 50 cosine 7 times, 4.4995. I can do a quick check, make sure I didn't get sine and cosine backwards, because this is 50 degrees. This angle here is 40 degrees. The side opposite the 50 should be larger than the side opposite the 40, and it is. So B, I go to the right, 4.4995 meters I hat, and I go opposite the direction of J. I'm going down, so minus 5.3623 J hat, and that is meters. And now the sum, so this is 8.8296 meters I hat minus 2.8623 meters j hat. And so this is my resultant. And I can leave it like that. If it depends upon the nature of the question. If the question is, what is the sum of those two vectors? Well, I have an answer here. This is just rectangular form. That is in polar form. If I ask what is the magnitude and direction, I'm now asking for something more specific. I'm asking, in essence, for polar form, although there is a different way of doing it if necessary. So now to find the magnitude of the resultant, notice that this is the double print indicating a vector. This is a single print indicating not a vector, or I could put the absolute value symbols around it, or the magnet. All of these mean the same thing. And so I just do Pythagorean theorem, because I'm going over a certain amount and down a certain amount. So I have that squared, that squared, and I have 9.282 meters. And the direction is, I know it's a fourth quadrant angle, so I'm going to basically find that angle right there. So 2.8623, 8.8296 divided by, so I'm doing the opposite over the adjacent, which is the tangent. So the tangent of, I'll label that angle theta, of theta is 0.32417. And so the angle is, and let's move this so it's actually on screen. So theta is the arctan of that. So 17.96 degrees. And so negative 17.96 degrees. If I just left at 17.96, that's a first quadrant angle. And so there'd be obviously a deduction. So that is it in polar form. We can now compare to my very crude estimate over here. My magnitude's, not too bad, close enough for physics. And this one's a little bit farther off, still not too bad given the crudity of my analysis there. So that's the addition. Now if I'm subtracting vectors, so let's start with the same two vectors here. So A is 5 meters 30 degrees and B is 7 meters negative 50 degrees. If I do A minus B, now from a graphing point of view, I had A, which was roughly there. I had B, which is roughly there. So that's A and that's B. Recognize that A minus B is the same as A plus negative B. And negative just means the opposite direction. And so negative B would be this way. And so when I add them together, my resultant is now pointing definitely a first quadrant angle there. This is negative B. And for just absolutely stunning, spectacular visuals and graphics. So I can come up with a crude estimate for what the sum is, but as we saw how accurate the last one was, and I'm taking less care this time. So it's a lot easier to put it into rectangular form. So this becomes 4.3301 meters I hat plus 2.5 meters J hat, and this is 4.4995 meters I hat minus 5.3623 meters J hat. A minus B becomes 4.3301 minus 4.4995 meters I hat, and 2.5 minus negative 5.3623 meters J hat plus negative 0.1694 meters I hat. I guess I don't need parentheses there. Plus 7.8623 meters J hat. And so there we have it in rectangular form. This is a second quadrant angle, and my crude estimate put it in a first quadrant, and that's because, well, I didn't make that long enough compared to this one, and my angles are off, etc., etc., etc. Let's go back to the addition problem here. There's another method for solving it where I have my 5 meters 30 degrees, and then I added my 7 meters 50 degrees, so I know that that's 50 degrees there, and that's 7, put it on the outside, 7 meters. And so my resultant, put the heads on, the resultant looks like that. And now we use some of the laws of trigonometry. Now, I personally find breaking it into rectangular notation or rectangular form and then adding a lot easier than what I'm about to do, but there are situations where it comes out better. So if that's 30 degrees there, then that's 30 degrees. That's 80, therefore that's 100 degrees. So I have two sides and the angle between them, so use law of cosine. So the magnitude of r squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of the angle between them, or the cosine of the angle opposite the side I'm trying to find. And my gut tells me it's somewhere around 9.282, but let's just go ahead and use the calculator. I get 86.1554, and so R is 9.282. Wow, that's what we had before. What a coincidence. To find the angle here, I now know this side right here, and I know its opposite angle, so I can use law of sines to find this angle right here. And so I have 9.282 over the sine of 100 degrees, is equal to 7 over the sine of, what do we call that, phi? Is that whole angle, sine of phi. And so phi ends up being, let's go through the steps. Sine of phi cross multiplying, so multiply the angle, the diagonal we know, divide by what's left over. So this is 0.74269, and then arc sine. So phi is 47.96 degrees. That's the whole angle right there. And so this small little sliver right here, that whole angle minus 30. And so we end up with an angle of negative 17.96 degrees. And that is what we had before. Given the presentation here, this was fewer steps than doing what I did before. However, there are a couple of careless errors that I almost made doing it this method. And personally, I'm less apt to make careless errors doing it the other way. All right. A third method for solving this analytically. Again, let's start with the same two vectors. I have A, which is 5 meters 30 degrees, and B, which is 7 meters negative 50 degrees. Now, when I did this the first time, when I did it analytically, or from the rectangular form, I set up my coordinate system, which I should, set up the coordinate system, and then I thought through the direction. I knew this was going down, and so therefore I made that a negative component. Now the method where a little bit less thinking involved, as long as your coordinate system is set up right. Since 0 degrees is to the right, I need to set up one of my axes in that direction. I'll set the other one up perpendicular to that in the classic XY brainwashing way that the math people have taught us. And so my resultant will be 5 meters times the cosine of 30 degrees I hat plus 5 meters times the sine of 30 degrees j hat plus 7 meters times the cosine of negative 50 degrees I hat plus 7 meters times the sine of negative 50 degrees j hat. And so I don't need to think through the direction. If you're writing a computer program to do this, this is really nice that it works out this way. And so the negatives that I had to think through before show up this time. And so this ends up as 4.3301 I hat plus 2.5 j hat plus 4.4995 I hat minus 5.3623 j hat. The sine of negative 50 degrees produces that negative sign there. And so we end up with 8.8296 I hat minus 2.8623 j hat. Now, if I left the answer as that, if you left the answer as that, I would take off 30% of the problem because you have left off units. And so to write units, I don't need to track the units as I'm doing the problem, but I do need units in the end. And so I'm going to write my final answer as 8.8296 meters I hat minus 2.8623 meters j hat. That is an acceptable answer. Also acceptable, 8.8296 I hat minus 2.8623 j hat. Hopefully I haven't written one of the numbers wrong. And then meters on the outside like that with the parentheses. That is also an acceptable answer. If you write 8.8296 I hat minus 2.8623 j hat meters, I will take off for that. So because this meters is only associated with this term right here, and you've left this one blank. And so this is not appropriate. These get the smiley face. This does not get the smiley face. And this right here gets the evil eye. And I've done better evil eyes, but there it is. Addition and subtraction of vectors.